share my screen. Just give me a second. Okay, so can you guys see my screen?
Yes, sir.
Yes, sir.
All right. So, so I'll just introduce first myself, who I am, and then we will go on to what parametric design is. So, like I said, I'm Kedar Undare. I am an architect, educator, and an artist. So, I did my bachelor's of architecture in India, and then I went on to do my master's in IAC, which is Institute for Advanced Architecture of Catalonia in Spain, where we did mostly computational design and parametric design, which is what I follow in architecture practice as well, where I use computational design to design furniture or building facades. So, for example, this is the facade done using radiation analysis. And since this parametric design is not new, but let's say it is new for our context, I like to educate and teach people about this by taking workshop and online classes under parametric thinking. And also I collaborate with organizations like ArchiterraX. I have collaborated with Interaxis Canada and also a few colleges, like this was the other one in Bangalore. And in my artworks, I engage with parametric design as a portal that allow machine to interact with intangible qualities like noise, music, gravity, sound. And this, the generative art that you see in front of you, was done using parametric design for a sound composer, Joshua, who wanted to see how his music looks like. So that's what I do as an architect, educator, and an artist. If anybody wants to get in touch with me, you can find my email ID below, which is kedarundare22@gmail.com. And you can also connect with me on my Instagram handle, which is at undarekedar, that is UNDALEKEDR. In case from today's workshop, anybody would like to share their work on Instagram, do tag me and also the ArchiterraX Instagram page. Okay. So this was about me and what I do. Now we will look at what parametric design is. Okay, so we'll look at what parametric design is, and then I'll give you introduction to Grasshopper, and then we'll do one example of parametric facade. After which we'll have a small Q&A session of around 15-20 minutes. So in this, whatever you have doubts, you can put it in chat or you can let me know later. Okay. So last year around this similar time, when pandemic started, everybody was creating this parametric design or parametric design groups, and I thought this field needs to be accessible to everyone, and so I created this thing called anyone can be a parametric designer. And there are not many things that you need to do in order to learn what parametric design is or to be a parametric designer. This is a bold statement that I'm saying anyone can be a parametric designer, but I do believe that anybody can be. And there are two main ingredients to, let's say, how that anyone can be a parametric designer. Okay, this presentation will be around for half an hour. If you guys want to get yourself a coffee or any drink, you can have it and just sit back and relax. We'll do the grasshopper part later. So the two main ingredients of parametric design, one is mathematics. So parametric design has always been associated with words like logic, algorithm, and data, and maths being the grandmother of them all. So there is always this association with parametric design and mathematics. But what if, let's say, you're not fond of maths? Okay. Mathematics need not be complicated. We know simple maths like addition and subtraction. So you can use even the most basic kind of maths to understand what parametric design is. There is a whole misunderstanding, let's say, that you need to learn trigonometric functions or it could be coding. But even if you know basics of mathematics, you will be able to do parametric design. And the second key ingredient is geometry. we have always connected with geometry as a kid, with shape, color, objects, and associating each geometry with another. And that is all that you need to know. Okay, but let's say a misconception is that a shape needs to be complex in order for it to fall under the category of parametric design. It is not true. A simple cube derived using parameters like length, height, and volume can also be termed as parametric object, which is what the first definition of parametric design was, that any object derived from parameters is a parametric object, which is somewhat true and somewhat not true. But for right now, we will say that anything that has parameters and has been derived from parameters, even a simple cube, is parametric object. So now you guys have the two main important things. One is maths, geometry, which everybody knows. And to visually see it, this is how, let's say, it would look like, where this bottom part is a script from Grasshopper. And here also, if you see, it is a simple use of subtraction and division to get this kind of a geometric output, which is just rotating of these ribs. And if you see, I have divided by 180 so that I get equal angles. Okay, this radians and these all other things, as of now, I don't want to understand. As of now, what I know, that I know the simplicity of maths and the simplicity of geometry. That is all it takes for me to understand parametric design. But what about when parametric design originated? What happened? Like, how did it? What about the past? Okay. As we know that mathematics plays a major role in parametric design, that is where the term parametric originated. And it was originated in 1839, more than 150 years ago, in a paper titled On the Drawings of Figures of Crystals by a mathematician, of course, because mathematics, mathematician James Rhino. Okay. So this is one of a snippet from his paper. And since most of us come from design school and architecture school, what about in the field of architecture? And in 1940, an Italian architect, Luigi Moretti, started writing about parametric architecture. Yes, after 100 years, it came in the field of mathematics. It took around 100 years to come in the field of architecture. But still, we see it is very new. And in 1960, around 20 years later, Moretti designed this stadium, which is not built, and this stadium had 19 parameters, like viewing angles, the economic cost of concrete, and so on. So if you see the shape of this stadium, according to Moretti, the central part would not require, because the people would not be able to focus on either side. So he would remove this part, and similarly for the viewing angles. So in 1960, and now we are after 60 years, we still consider parametric design or parametric thinking as a new ideology. Okay, so we need to little buck up, let's say, and that is something to think about. But there is one, let's say, one lack that we had, and which was technological resources, because of which there was this gap of, let's say, 60 to 50 years. Okay, and why is that? We'll see. So even though Sketchpad, the first parametric design software, was developed by Ivan Sutherland in 1963, you see the relationship between the model that was done by Moretti in 1960 and 1963. So at the same time, this everything was going on. But what was the major reason was the owning of a computer at that time was very huge. It was not until 80s when the computer became affordable to own personally, and after which a lot of softwares have come in. Okay, so the first one is AutoCAD. Let me tell you, AutoCAD is not a parametric design software, but we have it in this presentation because that's how we can relate to, because most of us know AutoCAD or we have used it in our college life or in our professional life. The first commercially successful parametric software was Pro Engineer, which was released in 1988. It had similar functions to Sketchpad, where the designers could explore different variations of the model by changing parameters. Okay, except that it was 3D instead of 2D. The only drawback with Pro Engineer was it could not handle organic geometries. And if you have seen many projects that come under the, let's say, category of parametric design, handling organic geometries is a very important thing that a software needs to be done. So then came digital project, which was developed by Gary Technology in 2004, and it was the software used to design the Guggenheim Museum at Bilbao. Okay, so the software had similar functions to Pro Engine and CATIA. CATIA is another parametric software mostly used by engineers. But digital project could also handle curvilinear or complex forms. That is what we see in the Guggenheim Museum, Bilbao. So this is the first software which architects um, were using because it could handle the curvilinear forms. Then later came Grasshopper 3D, a scripting based parametric software, which a lot of people are using these days, including myself. I personally like it because of its community, its wide ranging library, and the ability to iterate designs in a very short time. So that's why Grasshopper is very popular. Of course, after 2008, there have been a lot of developments again, where, for example, we have Dynamo, which is an extension, which is a parametric software for Revit. We have Houdini and Maya and a lot of softwares. Okay, it depends on what you like. You know, somebody might like using Grasshopper, somebody might like using Dynamo because they are working with Revit. But these are the recent ones are the parametric softwares. And this is why there was a gap in developing parametric designs. So till 2008, let's say there was not, or even till 2004, there was not a parametric software that could allow us to do things. So that's why from 1960 to 2004, there was this gap. But let's say that somebody doesn't want to use any of this software. Can't you be a parametric designer then? Yes, you still can. And there are a couple of architects who use parametric design manually. Okay. At the end of 19th century, there was an architect who manually designed parametric models. Okay, I hope you know this architect. His one of his building is still being built, and he's none other than Antoni Gaudi with his hanging chain model, which when turned upside down revealed the design. Okay, and what were the parameters he used? So the parameters that we used um, was this the length of the string, or let's say cables. Second were the anchor points, where are they fixed, and the third one are, if you see here, there are these weights. And what he would do is he would move any of these, and then automatically the arches or the catenary curve would change, and he would get every time a different iteration. If you remember from the software, they also had a iteration part to it. So that is something very important parametric design, to be able to create iterations. Okay? And when turned upside down, you would get this vaulted rhombolical structure. But this was way before when Moretti started writing about parametric design. So nowhere has Antoni Gaudi himself said that he used parametric design in architecture. But the underlying principles say that he clearly used. Okay, and like we saw the parameters from the previous page. And anything that would change slightly in those parameters would result in a completely new design output. This is a simple visualization of how a chain model works, where you are connecting these anchor points, and then you are adding load on these chains, and automatically by the self weight you get these hanging models. Okay. Another architect who did parametric design manually was Frey Otto, with his minimal surface derived from soap films. The architect would dip a woolen thread or a wire in a liquid in search for finding the minimal surface, and he used to call it form finding. In short, a minimal surface is a surface in between any two fixed boundaries. So now we have this fixed boundary here, this top rectangle, and these two circles. So a minimal surface is a surface which takes minimal curvature, let's say. Okay, this is a simple again visualization of how a minimal surface would work. Yeah. So even if anybody wants to do manual parametric design and has no interest of learning softwares, it is also possible. I have been trying to figure out few of the manual parametric designs myself, and there are a few of them, so you can do it. And but what is the key underlining, let's say, ideology behind all of this is to create systems. Okay, parametric design is all about creating systems, be it analog or digital. A system where change in one parameter, like we saw in the chain model, changes the whole design output. So that is basically what we need to understand is parametric design. Okay. So initially we knew that anything has parameters is parametric design. Now we have come to a stage where we understand that it's about creating systems, and it can be digital or analog. Okay. Now what we will do to understand anything, we have to define it. Okay. And I have created my own definition, which I think anybody can use it. Okay. But first, let's see what definition does Wikipedia has. Okay, so this is a definition given by Wasim Chabi, who is an author of book Parametric Design for Architecture. And he says parametric design is a process based on algorithmic thinking. Let's say this algorithmic thinking is maths that enables the expression of parameters and rules, okay, that together define, encode, and clarify the relationship between design intent, so what you wanted to do, and design response, what you end up doing. Okay, this, to be honest, is a bit complex. Okay, it's a little complex. So what we will do, we'll try to make our own simple definition. So from the words that we know so far, we know that mathematics and geometry are the two key ingredients. We know that we need parameters for it to completely change, and we also know that we need to create systems. Okay. Now, when we rearrange these words, now this rearranging of words is left to you, and you can arrange it in whatever ways you want. I have arranged it like this, where I am creating systems with the help of maths to change the geometry using parameters. Okay, and that's how I define parametric design as is a process of creating systems using mathematical algorithms that allow the geometry to keep iterating or changing with the parameters. So what is it doing is that we are creating system with the help of mathematics that allows the geometry to keep changing with the help of parameters. Now these parameters can be anything. Now in front of you, you are using a laptop or a computer. The parameters can be the pressure that you put on your keyboard. So depending on that, your the stiffness of the material is used. Then if you're using a mouse, ergonomics could be a parameter. So these parameters can be n number on any object. Okay. I call this simpler anyone can do definition. Okay. And as a fun exercise, even you guys can try. You can just use these 5 words, make your own definition, and you can share it with me on my. You can email it to me or you can share it to me. Okay. So this is what parametric design is. Okay, to understand in simpler terms, you create a system with the help of maths that allows geometry to keep changing with parameters. Now, if you remove this word maths, you can also put manually using manual algorithms. That's also fine if you want to create without the help of software. Now, where all is parametric design used? Okay. So this is what a Google image or Google search of parametric design is. Okay. And to be honest, initially when I saw this image, these are two complex things, and sometimes it becomes very intimidating to even try to do these things. We will look at some other things that can be done using parametric design. Okay, let's say it's a fun side of parametric design. You can use parametric design to create motion graphics, animation, game design, and digital art. Okay. If somebody has interest in cooking or bakery, parametric design is also thriving in those industries. like food, shoes, automotive, furniture, fashion. The cake that you see has been made by Dinara Kosko, a pastry chef and architect from Ukraine. So you see, there is no limitation. Parametric design is not restricted only to the field of architecture. You can use it to any field. And since parametric design is all about creating systems, it is used to investigate and mimic nature or natural forces like gravity, wind, and magnetic field as well. Okay? Parametric design can also make designers' life easier by avoiding repetition or correction over and over. So you can create n number of floor plans, n number of elevations, n number of sections. And of course, it is used for structural and environmental analysis. Okay. So you can pick any particular thing that you are interested in. It can be architecture, it can be structural engineering, it can be food, it can be automotive, and you can use parametric design there. It is not restricted to the field of architecture. It is an ideology that will help you to design. Okay. And so that's why I say that anyone can be a parametric designer. So this was a small presentation about what parametric design is. And trust me, I do believe that anybody can be a parametric designer. Okay? I hope you enjoyed the presentation. And now we will, I hope you all might have installed Rhino and Grasshopper. So we'll take a break of 4-5 minutes so that you can start your systems or Rhino and Grasshopper, and then we'll continue working on it. In between, if anybody has any questions, you can put up in the chat. Stop presenting. Our being software, structural engineer is Hi Pranav, your question is: Are BIM software is also parametric design software? Which exactly BIM software are you referring about? If it is Revit, Revit is not a parametric design software. Like I told you, there is a separate extension of Revit called Dynamo. That is a parametric design software. So there are few BIM softwares which are also parametric software. Uh, Aishwarya Omkar. Do structural engineer should use parametric design? Yes, a lot of structural engineers are using parametric design in their structural calculations. For example, there are few plugins like Karamba and other plugins which help you in structural calculations as well. So structural engineers are using parametric design. Are there any masters for computational design in India? There are quite a few abroad though. In India, as of now, I don't know any particular course that is fully given to computational design, but there are few colleges which have electives and which have extracurricular different subjects where they are inculcating computational design. Okay, there is one school, I think it is in Pune. Uh, yeah, yeah. I hope it's correct. It's Danish or Danish. There is one school in Pune. They have a master's course in computational design. I don't know the name of the school, but if you can email me and get in touch with me, I can surely let you know. Actually, I am in first year, so I don't know how to use software. Any suggestion for the beginner like me? Sachin, I would say that nowadays, after the pandemic, there are a lot of courses that are available online for you to learn. Okay, so I think that would be one of just go online, okay, and take. I would say I know it's like it is better to take a paid course than to learn directly from YouTube. Okay, so I would say it's better if you learn like that. There are a lot of paid course on Udemy, on there are Cadence. There are a lot of sites which can help you do that. How to learn in depth about parametric design? Mm, okay. Um, what do you mean in depth parametric design, Ritima? I mean, are you talking about software part or the theoretical part? Because software part is impossible to learn, you know, because I also don't know the whole software, and it's impossible to learn. It's like trying to learn uh, all the Adobe software. You can't. You learn that particular software for that particular thing. Uh, Yes, SM, we do get structural analysis result. There are different plugins like Karamba and Kangaroo and other where you get stress values and things like that. It's a paid plugin, so you do get stress values. Revit and Rhino, Dynamo, same type of script. Dynamo and Grasshopper are similar. Revit is different. Revit is BIM, which is building information modeling. Rhino is a 3D modeling software. But Dynamo and Grasshopper have same type of script. Also, there is something called Rhino Inside, which will help you to get those scripts, Grasshopper script inside of Revit. Okay, so we'll continue with these questions later. Now we will jump to Grasshopper. Okay, I need to take the questions from Sid. So Sid, I will take questions from you later. Now we'll jump to understanding what Grasshopper is. Okay. So I hope most of you might have installed the software. Okay, I'm just gonna share my screen. Yeah. Okay. So this is a Rhino viewport when you open it. Okay. Now there are two ways to call out Grasshopper. Either in the command prompt, you can just type Grasshopper, Grass, Grasshopper. If you have Rhino 6 and Rhino 7, Grasshopper is already installed. But if you have Rhino 5, then you will have to install it separately. Okay. So then you just type Grasshopper and you click on it. So this will take some time to load. Okay, it just takes 1 or 2 minutes. Just give it some time. Okay, so this is what a Grasshopper window looks like. Okay, I hope at least 50% of you might have installed. What I will do is you go like we will go simultaneously. I will not teach and then I will in between I'll give gap so you can do what I'm doing. Okay, so the first thing we make a new. So we go new document. So we go to file and new document. Okay. Now this visually, some of you might be seeing this as cream color screen with grid. I have removed it. Okay, it's okay. It is completely same. There is no difference. Okay. Now in Grasshopper, we call this whatever the background that you're seeing. We call this as canvas, on which we put components and we make a script. Okay, simple as that. Okay, and on top we will not look at Rhino because Rhino is mostly let's say a mix of AutoCAD and SketchUp where you're doing 2D and 3D simultaneously. Can you mute yourself? Somebody's mic is on. Okay. So, yeah. So in the top, if you see in Grasshopper, you have your similar functions like any other software. Inside file, you have document, open, close, save. Instead of edit, you have your cut, copy, paste, make a group, make a cluster, and so on and so forth. In view, we'll see this when we get to it. Uh, I would ask everybody to go to display and please on this draw icons, draw fancy wires and draw full names. Okay. So if you on it, you will see like this light blue color border around the logo. So please on these three, very important. Then solution is to, let's say now you do some changes in the script and you want to like see what changes you have made. So the solution. Okay, under help, under tutorial files, there are few of the files which have already been done for you. So you can click any of them. Let's say wires and conversations. Okay, so now you see there is something that is this is let's say tutorial that has been done for you inside of a Grasshopper. Okay, so if you want, you can learn these as well. Just gonna make a new document again. Yeah. And below all of these, okay, whatever you see these letters, those are called tabs. And each when you add a new install a new plugin, you get a new tab. Okay, so for instance, you guys might have params, maths, set, vector, curve, surface, mesh, intersect, transform, display, and K, which might be just Kangaroo, which is a physics engine developed by Daniel Piker. So these are what we call as tabs. Okay, and inside each tab, depending upon that particular title, you have those components. For example, under curve, I am going to have the components which are related to only curve. Under surface, I'm going to have components which are related to surface, and so on and so forth. If I go to transform, I'll have components like scale, rotate, move, array, and so on and so forth. Okay, so these are your components. Now, few of these extra lettering that you see, which are the plugins that I have installed, depending upon the work or what I do. Okay, so this is a basic overview of what Grasshopper is. You have tab, inside tab you have component, and you keep this component on the canvas. Okay, now we'll do simple how to take a component and see what happens. Okay, so first thing I will do is there are two ways to take a component. You go to params, geometry, you take a point and you put it on the canvas. That we have a component. Okay. Other way is that you, let's say now you need a point, you double click on the canvas and you type point. So you also get point. Okay. I would personally, I prefer to go to this way where I go to params, geometry and take a point, because then visually I see the neighboring components. Like I see circle, curve, plane, rectangle. Okay. If I simply type point, okay, I will see all the components which have the word point, but they are not related to each other. But whereas if I see the under param geometry, these components, there will be some connection to it. Okay, so I would prefer you go with this method. Okay, once you become perfect, then you can use directly. Okay, so this is how we call out a component. Okay, I'm just gonna use a plugin so that you see what component I'm using. Okay, you will not be able to see this, whatever the point written on top, because I am using a plugin called bifocals, which allows me to see what component I'm using. Okay, if you want to know what component you're using, you go to display and you off draw icons. So then here you will see the name of the component. Okay, go to display, draw icons. If you on it, you will see the icon. If you off it, you will see the name of the component. Okay, I personally like to keep it on. So it's a personal preference, however you want to use it. Okay, so now this is a component that we have taken. Now let's see how do you connect different components. Okay, it's simple. So we'll take randomly 2-3 components. So I go to params, geometry, circle, I will take, let's say, a plane, and I will also, I don't know, let's take a line. Okay, doesn't matter, any three components from params. Okay. Now, in few, let's say, schools or colleges, they also call these components as batteries because there is an inlet and there is an outlet. Okay, so you see each component has this semicircular inlet and a semicircular outlet. If you hover your mouse over it, below the arrow, you see this kind of a squiggly curve or an arc. Okay, this is how you can connect different components. Okay, so I'm going to connect circle to a rectangle, so it will automatically snap. Okay, one thing to remember, that you're always 95% of the times you're going to script from left to right. You're always going to script from left to right. You're never going to script from right to left. Never. It is going to be only in a very few cases, but 95% of the times you're going to script from left to right. Okay, and then I'm going to connect rectangle to the line. Okay, so this is how you connect different components. Simple. Now let's say I want to remove this. I want to remove this wire. Okay, how do you remove it? You can hold control. When you hold control, you see the curvilinear wire below the arc below the cursor has become red, and so you can remove it. So you add it, and to remove, you hold control or command. If somebody is using Mac, you use command. So you hold this and you hold control or command to remove it. Okay, simple. Okay. Now you might be seeing that these components are orange in color. Okay, one thing to remember, that Grasshopper has, let's say, three kind of color codings. Okay, those are similar to, let's say, traffic signal. Okay, where you have green, red, and orange. Instead of green here, we have gray. Okay, now what does each color indicate? Okay, now let me take a point again. So I go to params, geometry, point. Now, when you hover your mouse over any component, it tells you what that component is. So it says point contains a collection of three-dimension point. Okay, so that is what this component is. If you see below, it says empty point parameter. That means this component has no data inside of it. Okay. In other terms, you can say that this component is hungry and you need to feed it something. Okay. So whenever you see something orange, remember that component is empty. Okay. Remember that component is empty. Okay. And always read the component. It is very important. Okay. If you can read a component, you have mastered 30-40% of Grasshopper. Okay, it is very important to read a component. It is very important to know what it needs. For example, here contains a collection of circles. Okay, so now I know this particular component can take only circles. It can need only circles. I can't give it surface. I can't give it cube. I can't give it cuboid, which is a polysurface. Similarly, rectangle. It says contains a collection of rectangle, a line. So it is very important to read what a component needs or what a component requires. Okay, so this is one color coding. Okay. You can also take down notes inside of Grasshopper. So you go to params, input, you take a panel, input, and you take a panel, and here you can write it. You can double click and write anything. So I can say orange means there is no data. So it means that there is no data. Now, when does red appear? Okay, so basically red means error, like stop. Like how on traffic signal it is, red means we need to stop it. Okay, now let's see when does red appear. Okay, before that, let's see gray. So, okay. So now what I will do is I will go to surface, primitive, and I will take a sphere. Okay, I will take this one again. Oh, something has happened in the Rhino viewport. Okay, when we took this, something has happened in the Rhino viewport. Okay, you guys might be seeing a red or a green color sphere, which is fine. The color doesn't represent anything. It is just a visual representation. Okay. So I see something. So what I will do is now I will go to Rhino. Just take your mouse towards Rhino and zoom in. You will see this and double click on perspective. Okay. If you double click back, you will be able to. So in Rhino, you'll be working with different views. You can change it like front, right, top, perspective, any. Okay. I'm going to double click on perspective, and right now I have this view. Okay. To zoom in and zoom out in Rhino, you use your scroll. To orbit, you use right mouse click. Okay. Do not if you hit the scroll wheel to orbit, like let's say SketchUp, it's not going to work. Use right mouse click. Okay, so now I have this sphere that has come inside of Rhino. Okay, and from where is this sphere coming? I cannot select it. No matter what I do, I cannot select it. It is coming from this component inside of Grasshopper. Okay, now you guys might be seeing this red or green, I assume. You can change how whatever color you want it. Now, how do you change the color? So below these components, on the right hand side, you see these logos. You have something called as draw preview boundary. You have only draw preview geometry. Beside that, there is a sphere which is half orange and half white. Okay, so click on that, and here you will be able to change how you see the geometry when it is normal, that is when you have not clicked on it, and selected means when you have clicked on it. Okay, so right now if you see, I have this black color sphere because my normal is black, and when I select it or when I click on it, it becomes pink. These colors you can choose any. Okay, one thing that I always like to do is to add an alpha value, which is transparency. Okay, so always this is personal preference. I like to add alpha value. Okay, so that let's say inside this sphere there is like a cube, there is a cube here, so I can see that, and when I select it, I don't add an alpha value. Okay, then I say okay. So now whenever I click this sphere, it's going to become pink, and when I don't, it's going to become black. So it depends the color, you can keep it. Okay. Now remember, I told you to read a component. Now what does this sphere need? It needs a base. A base is world xy, which is fine, and a radius. So right now, this sphere is of radius 1, because here if I say one locally defined value 1. Okay, so that means it has a radius of 1. Now how do I change this? Okay, I can easily add a number slider to it. Okay, now let's say I want to change this to 2.5. Okay, I want the radius to be 2.5. So I can double click on canvas. I can type 2.50 and enter. So I get a number slider automatically. Okay, if you want to know where it is under params, input, and number slider. Okay, so then you connect this 2.5 number slider to the radius. So now the radius of this sphere has increased to 2.5. And if you like change the size, you will be able to change to whatever size you want. Let's say whatever. Okay. So there are two types of components inside of Grasshopper. Okay. One are these components, okay, which contain the data. For example, this contains the data, and these are the other ones which will help you to manipulate that data. Okay, in short, let's say these are raw materials. Okay, if you are cooking something, this is like a raw material, and this is the quantity of raw material. Okay, let's say you need salt. How many grams or how many grams of? So here, these are the quantities. So two type of components inside of Grasshopper. One that contains the data, and other that will help you to manipulate that data. Okay, so I can just copy this. So these are the second. So these are components and contain the data. And then these uh, components that manipulate the data. or you can call them as quantity of raw materials and these as raw materials. Okay. So now we have seen this. Now I was telling you about another color which is red. Okay. Now red means error. Okay. Now where do I see this? Okay. So let's go again. Let's go to surface, primitive sphere. Now logically, now you see that I can see sphere inside of sphere because this is one sphere and this is another sphere. That's why I like to add alpha value when it is normal, so I can see that oh there is another geometry inside it. Okay. Now logically I know this is a surface. Okay. But just to get that error, I'm going to do something stupid, let's say. So I'm going to go to params, geometry, point. I'm going to connect this sphere to the point. So it's automatically going to throw me an error. Okay. And here on the message balloon it says data conversion failed from surface to point. If you are unable to see this message, go to display, canvas widgets, and on all of these. Go to display, canvas widgets, and on all of these. Like compass, align, Markov, profiler, message balloon. Message balloon is what we saw. Okay. Canvas widgets, profiler is something. So under this point component, you see 11 ms. Okay. So profiler tells you how much time each component takes. Now this might depend on computer to computer. It takes 11 millisecond, I think microseconds in mine to compute this particular component. Okay. Maybe some of you don't see it. So that means that the RAM or the graphic card that you have is better than mine. Maybe some of you see it as 20 ms. That means the RAM or the graphic card that you have is lower than my configuration. Okay, these numbers right now they seem very small, but when you have a longer script, this number goes on to 1 minute, 2 minutes, and so on and so forth. Okay, so these are just the simple color coding that you have inside of Grasshopper. Okay, and you can also group scripts. So let's say now I want to select this script. I can group it. I can just say Command G on my keyboard or Control G. So now I have this one group. I can group all of these together and then say another group. I can also group them so that it's little neat or readable. Let's say. Okay. Another thing to remember that let's say now you have two spheres, one is inside the other. Okay, so now you don't want to see the sphere that is inside. If you don't want to see the sphere that's inside, what you can do is this is a sphere that's inside. You can select it, right click, and you say preview off. So you don't see the sphere that's inside. Even if you want to off the sphere outside, you do the same thing, right click, preview off. So basically, we are hiding the geometry, let's say. The geometry is there, we are not deleting it, we are hiding it. So we are just telling it to preview it off and then preview it on. Yeah. You guys can take 1 or 2 minutes if and then just understand what each color is, take random components, connect them. Okay. Till then I will see if there are any questions on the chat. Okay. So Sid, a student from BH, can we use this parametric design in our curriculum? Means it is handy for us to work with. Definitely. I mean, right now, uh, there is not a like they have not implemented this as a constant curriculum. But I know few of the colleges who use it as elective and who use it as for let's say an extension of the design course. So definitely you can use it in your curriculum. Can we refer to any book about parametric design? Anurag, there are two books written by Arturo Tedeschi. I will write it down. Those are really good books on, well, those specific to Grasshopper. Okay. If you want theory of parametric design, then you like send me a message or something. I will let you know the books. But if you want specific to Grasshopper, you can look at the books by Arturo Tedeschi. This is the first book, AAD, Algorithms Aided Design. And the second book is called Parametric Architecture with Grasshopper. So this is the second book. But these are only two related to Grasshopper. If you want to read the theory or something, how you copy panel, Control C, Control V. Like just like Command C, Command V or Control C, Control V. Can you suggest some paid courses which are good, Arjun? Uh, there are a lot of paid courses. Like I was saying, you can go to Udemy or Catons. We are also trying to come up with new courses for parametric design, so you can join us as well. Um, yeah. Shubham, to get into any of the abroad colleges which deals with computational parametric, and how important it is to have a base knowledge of these softwares, or do our portfolio must contain and glimpse of parametric? Shubham, it is not 100% important to know these softwares if you have to join, if you have to go to any abroad colleges. What is important, but is that they see that you use these kind of designs in your undergrad. Okay, so let's say that you want to go parametric design. Even at least nowadays, you have accessibility to these kind of software. So I would say that try to use something so that the colleges abroad know that you have interest in parametric design or computational design, let's say. Okay, when I was in my undergrad, we didn't have so much accessibility to these softwares. But what we used to do is we used to visually kind of represent it, take linear forms, and that's how our portfolio could look like it has used parametric design. But now, since you have accessibility, you don't need to know 100% of the parametric software. But even if you use it for, let's say, one semester and put it in your portfolio, I think that would be enough. Do we need to learn every plugin to become good in Rhino? No, definitely not. You don't need to learn every plugin. I personally don't know every plugin that is available inside of Rhino and Grasshopper. What you need to know is the logic behind what you're doing. So now we'll do one example of a facade. So what we call this in Grasshopper terminology as a pseudocode, where you sketch and then you understand what to use next component. So that even if you don't know that there is some plugin that exists, you can Google when you know the process or a pseudocode, let's say. How is it different from generative design? Or is generative design an umbrella term that includes parametric design? Uh, well, parametric design and generative design are separate. Okay, like we said, parametric design in simple terms, generative design will give you n number of generations of a design. Like let's say n number of iterations of a design. Whereas parametric design will give you only that particular design that you're working on. Okay, so if you have, I don't know, maybe I can tell you later after we finish the example. Uh, like there are few of the plugins like Galapagos or Silvereye, which will give you n number of generations of a design or iterations of a design. That you call it generative design. Can we design parametric shapes in SketchUp or Grasshopper? No, you can definitely design parametric shapes in SketchUp. What Grasshopper does is it will allow you to, now let's say, like for example, I have this sphere that is on my screen. Let's say I do some process, okay? I kind of explode it, I take a part, I do an arch out of it. Now, later I feel like, no, the radius of this should be 4. In SketchUp, what I would do is that I have to repeat all the steps. Now here I can just double click, say 4, enter. So then the whole process is, since it is connected, it will get updated on its own. So that is a difference between parametric modeling and non-parametric modeling. But of course, if you want to do parametric shapes, you can do it in SketchUp also. How is Rhino interface with respect to other softwares, like importing something from AutoCAD? Yes, you can. So Rhino is compatible with 30 file formats. You can import with SketchUp, AutoCAD, 3ds Max, Maya. You can also use it with different fabrication machines like CNC cutting, laser cutting. So you can directly import the Rhino file to these files as well. And in terms of interface, it is very similar. So like you can just draw a cube. Yeah. So you can draw a cube, you can draw a sphere. I mean, it's basically it's simpler. There's nothing problem with interface. How is the scope of parametric designing in India in terms of work and demand? Hi Guru, there are a lot of offices and companies right now looking for parametric designers. Okay, like we don't have jobs that have been specified as parametric design or parametric designer, but I know a lot of offices which are looking for parametric designers, and I'm sure in a couple of years, 2 to 3 years, there is going to be a highly demand for parametric designers in India as well. It's in Grasshopper, every process is recorded, so it is very helpful. Yeah, Sumit. So in terms of what every process recorded is that we have all the components here. So now if I explore this sphere and then connect it, so all these previous steps are available with me to, let's say, change or reiterate, and that's why it's helpful. Okay. So it doesn't seem like you have any other questions. Okay. So now we'll continue. Okay. I hope you understood the basics of what Grasshopper does. Okay. Now we'll look at one example. Okay. We cannot, since it's only introductory class, like we cannot look at the whole basics of it. So what I will do is I will do a facade. Okay. You guys can do it with me. I'll explain you each and every step. There might be few things which you might not understand because those belong to the as of now, understand is a data structure that something goes behind it. Okay. So we'll be working on this particular example. Uh, just a second. Okay. So what we'll be working on is this particular facade, which is AU office and exhibition space done by Archune and architects in Shanghai. The logic of this is similar to all of these other buildings, which is working with attractor. Okay, so basically attractor point or attractor curve is that if you see in this image, the circles are becoming small as they come near to this curve, and they're becoming big as they go away from this particular curve, and that is the logic. Okay, similarly to this office building in Germany, where you have hexagons that are becoming big at the center and becoming small at the edges. Similarly, for this crematorium that has been done in Belgium, of course, they are not entirely the center. Let's say we have an imaginary curve, something like this, and they are becoming small and big with respect to that. Same is with this Al Bahar Tower, which most of us might have seen an image. If you type parametric design, this is the third or fourth image that comes up. Okay, and similarly here, what is happening? That a few of the panels, with respect to the sun's radiation, they have sensors inside. So these are opening more, and as you go, let's say here, maybe this is south side, and so they are opening less. The another example of this is Aqua Tower by Studio Gang in US. So this also works similarly with attractor. So if you can imagine, there is like a curve here. There is curve in these undulations that are going inside. So those are going inside, and wherever there is not a curve, it's going outside. Okay. So this is what we will look at. Basically, it's called attractor point, or we call it creating virtual magnets. Okay. We will look at this particular example. Yeah. We can it can be done in half an hour. Okay. I will go step by step slowly, but there might be few things which might not, because it relates to data structure. We have to understand data sets and all that. Okay. So let us start doing this. It's simple. Okay. The first thing that we will do is we'll create two walls. Okay. So what we will do is so if you see this project, the wall is not parallel. So the wall is a little undulating. So what we will do, first step is that we will create an undulating top edge of the wall. We will create bottom edge of the wall. This is our step 1. This is our step 2. Then we will make this wall. Okay. Simple, very simple. This is our step 1. Then in the next step, what we will do, okay, this is exactly what I was telling about the pseudocode to understand what goes behind it. Okay, now you will not get this in first go. So you have to do multiple iterations. So then in the second step, what we will do is we will divide this wall into different sections, okay, of whatever shape the wall is. So we will divide this into these sections. Okay. Then what we will do after this, we will create this one unit. Okay. So basically, if you see this one unit, it is like a cube which has a puncher here. So it has a puncher here. Okay. So we'll create one unit. Then what we will do, so this is separate. Then at each of these, whatever sections we have, we will create a plane. Okay. In Grasshopper, it's very important to understand planes. Right now, it's fine. Okay. So we will create these planes. So we'll create these planes at calculated distance with respect to this particular brick, let's say. Then we will move this brick to all of these places. We'll move this here. We'll move this here. We will move this here. We will move this here. Okay. Simple. Then later we will see how to rotate it. Okay. So this is our first step that we will do. 3 steps. Then later we will see how to rotate it. Okay. So let's go to perspective inside Rhino. This is going to be okay. Remember to use your right mouse click to orbit and not the scroll wheel. Okay. So first thing first, we will create this undulating top wall, top edge of the wall and bottom edge of the wall. Okay. So we'll just create a point. Okay. Always remember you're going to work with the most basic thing when you're working on Grasshopper, which is point. Then you work with curves, then you make a surface, then you make a solid, and then you get the final output. Okay. So we make a point. So we go to vector, point, we say construct point. Okay. Now we have the point inside of Rhino as well. Okay. Now what I want to do is I cannot directly make this undulating lines. But what I can do is I can create a series of points and then move them front and back randomly. Okay. So we will array these points or basically create multiple copies of it. So we go to transform array and then we say linear array. Okay. So what does linear array need? It needs a geometry, direction and count. So the point output of construct point goes to geometry. Okay. Now you see we have automatically 10 points because the count is 10. Let me increase it. Let me increase it to around 40. So we have 40 points. Okay. Now direction right now is X. Okay. Which is fine. But I want to add it. So every time, okay, even if the direction is correct, always remember to add all the components so that you know what is happening. So we go to vector, unit X. Okay. Connect it to direction. Okay, now you see the points have come close because the distance between each point is 1. So if you hover your mouse over direction, it says 1 value inherited from source, 1 which is X, 0 which is Y, and 0 that is Z. So it's X, Y, and Z coordinates. I want to increase this gap. Okay, I want to make it, let's say 2. So I'm going to say 2.0. connected to the factor. So now I have 40 points in x direction with a distance of 2. Okay? Simple, nothing overly complicated. Now I want to move these points randomly in y direction. Okay? So because right now I have points in x, this is x. I will have to move them randomly up and down in y direction. So what do? We move them. So we go to transform Euclidean move. Okay. Now what do you, so always remember which component are you connecting. You cannot connect construct point because it will only move one point. You need to move linear array which has all the points. So that's when you always click the component. So when I click the component, I see only, oh no, this is the one. I don't want one. I want all of them. So I'm going to connect this. So this goes to geometry. Okay. And then the motion that we want is in y. So we go to vector, we say unit y, and then this is goes to the motion. So now you see all of them have moved, but with a distance of 1 because the factor is 1. Now what I want them to move randomly. Okay, I don't want them to move 1, I want them to move randomly up and down, so I get the bottom edge of my wall. Okay, so we'll use a component called random. So we go to set sequence random, and then the random goes to the factor. Okay, so nothing yet is happening, but I see there is some sort of a movement. There is little movement, but not much. Okay, now why is that? Because the number we have is 1 in random, but how many numbers do we need? We need 40 numbers because we have 40 points. Okay, now how do you read this? You can connect a panel. I'm just connecting a panel, so the random connects to a panel. So now you see, since my number is 1, like it has only one number, it is giving me one random number. I don't want one. I have 40 points, so I need 40 random numbers. So I can simply connect this 40 of the count to the number. So now I have 40 random numbers. Okay, which are in a range of 0 to 1. And so basically range here, if you see, one locally defined value is 0 to 1. So these points are going to be in an interval 0 to 1. Let's say I want to change it. I right click on range, I say set domain, I say 0 to 0.75, and then I say commit change. So you can change it. You can say 0 to 5. So now you see they have moved little more in y direction. You can right click back. Right now I need 0.75. Okay, so I don't want more than this. Okay, simple. Let me reduce the Rhino viewport so that if somebody wants to take over the script, they can. Okay, so this is what we have done. Simple. Now we join these points. So we go to, so what we need to make? We need to make a curve. So we go to curve, spline, and then we say interpolate. Now where are my points that I want to join? They are inside of move. So geometry output of move goes to the word. So now I have this one random edge of my ball. Okay, I can preview of this. I say right click preview, right click preview, right click preview, right click preview. So I see only this particular line. Okay, you can also change how the points are moving. Okay, so inside this random there is something called as a seed value. Right now it's 2. Okay, let's say you add something called 20. So now when I change this, you see how the line is changing. Line. the form of the line is changing. So basically, it is creating random numbers with this particular seed value. Okay, it's not there's nothing. Logically, what's happening is it's creating these random numbers with a random seed. Okay, so this is my bottom edge of the wall. Now what I need top edge of the wall. Okay, so the easier thing to do for me right now is to group this. So I'm going to select this, Control G or Command G. So I can write the name bottom edge. Okay, this is my bottom edge. Okay, now I'm going to copy this whole thing. So just select everything, Control C, Control V. Now we have one more edge. We don't see it. Okay. Now how do I get this wall on top? Okay. If you remember, we used a component called construct point, which has x coordinate, y coordinate, and a z coordinate. Okay. I can directly add a z coordinate. Okay. So I can say instead of 0, you start at 50, 50.0. And this I can connect to the z coordinate. So now we have the top edge as well. So this is the top edge. So the bottom edge and the top edge. Add this. Okay. So these are our two edges, the bottom edge and the top edge, which is what we did in the sketch. Now we need to create a surface out of them. Okay. So since we need to create a surface, it's going to be under surface. So we go to surface. I think it should be under free form, and it should be something called rule surface. Yeah. So rule surface is a component which will allow you to create surface between two curves. So my curve A from interpolate goes here, and the curve B. So we have this kind of a wall. Okay. So this is my.
Looks good, sir.
Okay, thank you. So this is wall surface. Okay, so this is the wall that we have. Now at the next step, what we need to do is we need to create these horizontal sections. Okay, we need to create those horizontal sections. We need to create this kind of a brick. Okay, and then oriented on this. Okay, so let me drag this here. Okay, now first thing we'll create a brick. Okay, so this brick is going to be small, so I'm going to go here. Okay, so first thing we'll create a rectangle. So we go to curve, primitive, and then we say rectangle. Okay, so this is the rectangle. Now the size of x and y you can decide, since in the image it looks like a cuboid, so the x and y are going to be same. So I'm going to say 2.00. So this goes to y, this goes to x. Okay. Now right now, if you see that this rectangle is in xy plane, we need to make it vertical. So that means we need to change the plane. So we go to vector, plane, and then we say xz plane, so that it becomes vertical. So we connect this. Okay, simple. So we are just kind of connecting it, rotating it from xy plane to xz plane. Okay. Now, if we had seen that image, the cube, whatever this cuboid, had a central opening. So we will create. So now what we will do? We have our this rectangle. We will create another rectangle inside. Once we create another rectangle inside, we can make this as a surface. So this can easily be converted into a surface, and then we can give this a thickness. Okay. So inside automatically we will have these thicknesses as well. Okay. So in short, we need to scale this. Okay. Of course, there is another way where you can find the center and then we can scale it proportionally. Right now, let's just scale it. So we go to transform a file, we say scale. So what do you want to scale? So the scale has three inputs: geometry, center, and factor. The factor right now is 0.5. I will make it to 0.7p. Okay. The geometry that you want to scale is our this rectangle. So now you see that there is a rectangle inside of another rectangle. Okay, but it's not at the center. It is somewhere inside. So we need to find the center of this rectangle. Now, how do we do it? We use a component called area. Okay, so we go to surface analysis and area. Okay, and so this rectangle I'm going to connect to the geometry, and the centroid goes to the center. So now automatically it has moved to the center. Okay, now we will create this surface. So we can again use the same ruled surface. So we go to surface, freeform, and then ruled surface. This is my first surface, this is my second surface. Okay, so automatically I have the front or the one edge of the facade, okay, of this cuboid. Then what I want to do is I want to give it thickness. Now from the image, I see that the thickness is also same. So this is basically a cuboid. So thickness is also same. So we will extrude this. So we go to surface, freeform. We say extrude. We will connect this. Okay. Right now I can preview of this plane, this rectangle, the center, the area. Okay, because I don't need it. Okay. So we will extrude this surface which goes to base. Now the direction is very important. The direction here is y. So we go to vector, a unit y. Okay. So you see every time that you are doing something inside of Grasshopper, you are telling it what to do. Okay. It's not going to automatically do something. Whereas inside of let's say it's basically like you're working in SketchUp only, but you're telling it each and every step. You have to extrude in y direction. You have to give it this thickness and so on and so forth. Okay, so we give it a thickness in y, but we know that the size is 2, so we're going to connect the same 2 to the factor. Okay, so this is our block. Let me group this as well. So this becomes our so this becomes our one block. Okay. Now what do we do? Now, like we said, we need to create these horizontal sections. Okay? Now the horizontal sections you can easily create by a component called contour, which is going to create these kind of vertical sections. Is going to create on that particular surface. Okay. So we say contour. I think it should be under. Yeah, it is under intersect, mathematical, and contour. So it says create a set of BREP or mesh contours. Now, on what do we want this horizontal section? On our wall surface. Okay, very important to know which component is doing what. So this surface goes to the shape. Okay? The point is immaterial. The direction that we want this sections is in Z direction. So we go to vector Z, connect this to the direction. Now what's the distance? The distance between the sections is going to be the height of the brick. Okay. So right now we know that the height of the brick is 2. So the same 2 goes to distance. It's gonna take some time to load. Okay. So now you see on this we have contours with a height of 2, which is the height of the block. Okay. Yeah. So next step, what do we need to do? Is we need to create now, because you see, okay, none of those lines are parallel lines. If you see, none of these, every line has a undulation. Every line has an undulation that's coming on top. That is why we need to create a frame on top of it, like a perpendicular frame. So if let's say this is an undulation, there needs to be a frame like this, so that our block can come and rest here. And if this is the undulation like this, there needs to be a frame like this, so that our block can come and rest like this. Okay. If it was parallel lines, if it was simply like straight lines, then it would be much more easier. We don't need to do anything. We can just divide these lines into points and then move our cuboid. Okay. But since these are undulating lines, we need to do one more step. We need to create perpendicular frames, or in this case we have it horizontal frames. Okay. So where is the so we go to curve, division, and then we say horizontal frames. Okay, because we need them horizontally. I will take them. And where do we need it? On this each of the curve. So the contour connects to the curve. Okay, so now you see automatically we have these horizontal frames. Okay, and now what's the count? Let's make it a little big. Let's say the count as 50. We have these many. Okay. And then they all are, if you see, that they are following the curve and are not flat. Okay. Then what do? We now need, we can move this cuboid to each of the frames. Okay. So we use a component called orient. I am using a lot of components, but this is just to show how a script works. So you go to transform, should be under fine. Yeah, it's under transform, Euclidean, and orient. Okay. So what we want to orient is our cube. Where do we want to orient is our horizontal frames, which is a target. What's the source? The source is going to be the center, which we already have here in the area component. Okay. So the extrusion goes to the geometry. Okay. Then the area or the centroid goes to the source. Like this. Okay. And the frames goes to the, so the frames are the ones which are our target. Okay. So the frames goes to, it's going to take some time. So now everywhere we have these blocks. review of all of this because this is what we need. Of course, they are right now intersecting and all that. We'll see how to remove. That's not a concern. Okay. You guys can take a minute or two to come here if somebody is working on it. So I'll pause for 1 or 2 minutes and remember to save the file always. Okay, another 10 more minutes and it will be done. In case we want to do some kind of parametric paneling whose position is determined by the intensity of someone, we have to follow the same procedure. No, then the process will differ. So first you need to find out what kind of paneling you want. Is it a hexagonal paneling? Is it a diamond paneling? And then you need to use a plugin called Ladybug, which will give you sunlight analysis or sunlight hours. And then depending upon that, you can make the paneling. Or depending upon the radiation that you get, then you can choose whether you which panel can be you want it to be there and which you don't want it to be there. Okay, so we will continue. Okay, now if I have to see the image, okay, you see the alternate block is not there. Like, for example, if this is 0, 1, 2, so basically all the odd numbers are gone or in hi Guru, yes, you can do that as well. You could have created two cuboids, take boolean function separate, and why I did it here is because I wanted to show the whole thing inside of Grasshopper. Like, let's say that now you want to increase the size of the cuboid to 3. So then automatically here the size of the cuboid will increase. So that's why I am scripting it. If you want, you could have done it like you said inside of Rhino, make two cuboids, Boolean difference, and so on. Okay, so the next thing that we do is if I was telling you about the image, so we need to remove alternate. We need to remove the alternate blocks basically. Okay, now how do you do that? Okay, now imagine that they are in a series of true and false. Okay, imagine that this whatever the keywords that we have got is under a series of true and false. So it's like true, false, true, false, true, false, true, false, so on and so forth. Okay, now what we need to do is we need to remove alternate, or basically we need to remove them in a pattern of true and false. Okay, so even if you don't understand this, so imagine that this is 0, okay, 1, 0, 1, 0, 1, 0, 1, and we need to remove all the ones. And in the next line, We need to, so this will be like this, 1 0 1 0 1 0, and then in the next line we need to remove again all the ones, so that this is one block, this is another block, this is another block, this is another block, this is another block. So basically we remove the alternate blocks. Okay. To do that we use a component called cull pattern. Okay, so we go to set sequence and we say cull pattern. Okay, and now what's the pattern? Okay, if you see it as pre-fed pattern, okay, let us just connect it and see what happens. Okay, one step you need to do it here is that you need to write, this is very important, right click on, or just go to set tree and say flatten tree. Okay, this is very important. Okay, I cannot explain in this short time, but go to set tree and say flatten tree. Okay, connect the geometry output of orient to tree. This is very important. Okay, and then connect the tree to list. Okay, so now you see what's happening. Let me preview this off. Let me preview this also off. Okay, so now you see it has been cull in a pattern of, what's the pattern? False, false, true, true. So what is doing? False, false, true, true. So false means it is removing. Okay, here also you can see false, two trues, two false, two trues. So that's why we are getting this kind of pattern. But we don't need this kind of pattern. What we need a pattern of true and false. Okay. Okay, so we need a pattern of true and false. So we can simply go to panel, we go to params, input, panel, we can double click, right here true and right here false. Okay, and then connect this to cull pattern. Now this is throwing an error. Okay, so now you see it has thrown an error. Let us read what the error is. Data conversion failed from text to boolean. It's fine, it's not a problem. What we just need to do is we right click on the panel and we say we pick this multi-line data. Okay, so now we have alternate bricks or alternate blocks. Yeah. Okay, another 3 to 4 minutes. Now we need to rotate it. Okay, so what do we need to rotate? We need to rotate it. Okay, now we need to rotate with respect to an attractor point or an attractor curve. Okay, so what I will do is, first thing I'll go to the front view. Okay, and then let's just draw a random 3 lines. So I'm just going to inside of Rhino. Okay, so you can just draw any lines. Okay, you can just type line, 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 and then you can draw it anywhere you want. So let me, I'm drawing this one line, and this is another line. Okay, now with respect to these 2 lines, the facade has to rotate. Okay, so first thing, so these are my 2 lines. Okay, so first thing we'll set up everything to rotate. Okay, now we need to go to transform, Euclidean, and we need to rotate around an axis. So basically what those geometries need to do, they need to rotate around the axis. So we'll take rotate around axis. Now the geometry that we want to rotate are our geometries. Okay, right now it doesn't matter, complete doesn't matter, it's rotating like this. We need to add an axis. So basically what is an axis? Axis is an center line. Okay, so basically if this is my cuboid, axis is the center line. So if this is the center, this is another center, I just need to create an arbitrary line. The length of this line is immaterial. This is just to create an axis along which this will rotate. Okay. So what do we do?
Sorry to interrupt, Architect Kedar.
Yeah.
We are running short of time, and I would
Yeah.
request you to summarize it as early as possible. Thank you.
Yeah. Okay. So just to yeah. So it will take another 5 minutes because in between I took the question and answer. So we can. That's fine. Just 5 more minutes. Okay. So we just need to create a line. So we go to. So I'm just gonna create it a little faster. Let's say. So we create area to get the center lines. Then we move them. We move this centroid a little bit on top, and then we can just create a line. We create a line between these geometries, this one and this one. Okay, so just we're just creating arbitrary line. So this becomes the axis of rotation. Now they will go back. They will not rotate it. This angle I'll rightly can convert into degrees. Okay. Now the next thing that I need to do is to take these two curves. So I go to params, curve. I right click. I say I will say set multiple curves because I need to take two of them. I'm going to select both of this and hit space. So I have curve inside. Now with respect, now this part, since let's say lack of time, I'm just going to do it a little faster. So here we need to just convert it into an attractor point or attractor curve. So the first thing that we need to do is we need to take the centers to this curve. So we use a component called pull point. And these are my centroids and this is my geometry. So then we are pulling them together. And now we need to rotate them by adding an angle. Okay. So right now I have distance. If I see my output is, I can directly connect distance. Okay. So with respect to this, they are rotating, but they are not rotating too much. So to let's say accentuate the rotation, I will need to do some kind of different steps here. That is to create a new set. Okay. So I go to math. So basically now what I'm doing is I'm creating a new set. So the distances were between 1 to 33. Now I want to create a rotational angle between let's say 90 to let's say rotation of 90 to 45 degrees. 45, but let's say in and this is, yeah. So now we see that with respect to these two lines, okay, wherever so wherever this line is there are the two lines that we have done. They are rotating there, and in the center they're rotating on the opposite side. Now this one we can change it. So this is a better view. I can make a circle. Let's say I just make a circle, something like this, and then I can select. Let's say set one curve, and then I can select a circle as well. Okay. So now you see there's rotating. I can move this also on top to there. Okay. So now you see that they are rotating with respect to that circle. Okay. Yeah. So with here, wherever the circle is, they are rotating in one direction, and here they are in the negative direction. We can also change the degree. So I can change this degree to let's say 45, whatever. So now it looks something like this, where in the center part it is straight, that is 45 degrees, and they are going negative direction. Okay. Okay. Once everything is done, to take your geometry from Rhino to from Grasshopper to Rhino, you need to bake it. So you can select this, right click, bake it. You can go to default layer. You can make a group as well, and yes, say yes please to make a group. And yeah, and now we have them. So the first have done. is now yeah. Whatever the facade that we have done with respect to the circle as an attractor, we have it here. Okay. So this is how parametric design works, where now if I change any of these heights, now let's say that I make the height as 50 to 60, then again everything is going to change. Okay, so I will leave this script here like this. If anybody wants to complete, they can. We can have 10 minutes. I think we are almost running out of time. We can have a 10 minutes Q&A. Before that, just a second.